Hello, welcome to the Lab 1 of Mechatronics course. In this first lab, the main objective is you're going to measure temperature using a thermistor. The thermistor is a device that changes its resistance according to the temperature, and then you're going to build a voltage divider using this thermistor and a fixed resistor, and you're going to use your PSOC to calculate the temperature and display it in an LCD device. I'm going to introduce you to the main hardware that you're going to use on the lab one. This is a breadboard for those who never used the breadboard before. It's a way for you to connect your components. In this area of the breadboard, all the connections are in this direction. So all these holes are actually the same point in the connection. This area of the breadboard and this area of the breadboard are isolated. So if you want to connect this area to this one, you need to use a jumper here. And in this section of the breadboard, all the holes in this line are the same. So this line is isolated from this line, but all these holes are the same. After this bigger division here, this is another set of lines. So if you want to make these lines the same, you need to use a jumper here and a jumper here. Okay, the devices that you're going to use, this is our PSOC board. This is basically our main controller, microcontroller that we are going to use for all the projects in this lab. And here are the devices that you're going to use specifically for this one. This is a 10K ohm resistor. This is a thermistor. The thermistor is a device that changes its resistance according to the temperature. Specifically, this thermistor, whenever the temperature increases, its resistance drops. And you're going to develop a way to measure the temperature using a voltage divider composed by a resistor and a thermistor. The result that you calculate, the temperature, should be displayed on this LCD device that you're also going to control using your PSOC. Good luck. Okay, so most of you probably already explored a little bit of PSOC Creator platform, but just as a possible help, PSOC Creator comes with a series of code examples that you may use. And if you go to File and open Find Code Example, you'll be seeing a list of possible examples here. If you come to Device Family and choose the family of your device, that's PSOC 5 LP, it filters the examples. And for these specific Lab 1, what you may use is the thermistor calc example. That is a built-in example that basically performs everything that you need to do. But we strongly advise you to use your imagination and your creativity and develop your own solutions for this problem. The thermistor calc example uses some built-in functions to calculate the thermistor curve, but it's a bit complicated for you to calibrate these functions. Okay, whenever you open the example, it also opens the data sheet for this example, where it basically explains a little bit of the program and what are the blocks that are being used. If we come back to PSOC Creator, you may see on the top design and the schematic part how the problem was solved. Also, as you need to use a character LCD, it also uses the built-in function for the character LCD. Every block that you use on PSOC Creator you can access their data sheet in case you have any doubts on how to use the functions. So if we open here the character LCD data sheet, you're going to see how to use the block and which are the commands that you need to use on your written code in order to operate this device. Okay, So this is basically the idea behind using PSOC Creator, and the examples. I believe they're going to be very useful to you, especially to understand how to use the LCD. But we strongly advise you to come with your own solutions. Okay? Good luck. So once you have everything running, what you should see is the temperature displayed on your LCD, and it should react as you touch the thermistor. For example, if I hold it with my fingers, the temperature starts rising, and as you can see, the resistance starts dropping. And if I let it go, the process starts to revert, and the temperature starts dropping again, and the resistance goes up.